Hello, I'm your instructor for Physics 114, Mark Davidson, and this is the Scaling Lab video. So, you should have received this lab via email, and what we're looking at is the first page, and one thing that we want to note on the first page are these formulas. These formulas are what we're going to be using for the next part. Now, the next part is kind of weird because we're not actually going to be doing any experiments for the first part. We're just going to be using what we know about cubes, and what we know about cubes is summarized by these formulas. So, what you're going to be doing is you're going to be taking those formulas and you're going to be filling out this table. See, it asks, okay, so basically, and remember, when you're doing the table, these are the formulas you want to use. I have numbers of people who just, I don't know, go off on their own, and I end up with strange numbers. So be careful with that. All right, so then you'll use this table to fill out these questions, and one last one of those on the back there. The thing to remember about these questions is that the word factor means something that you multiply by. So if you're going from, say, 2 to 6, okay, the factor would be 3. The term would be 4 because 2 plus 4 is 6. But the factor, that's what you multiply by. You would multiply by 2 by 3 to get to 6. So that's the thing to remember about these questions. All right, and then here now we're going beyond. With this, now we're going beyond theoretical cubes to actual spheres. So let's measure some spheres. Okay, so now let's measure the ball bearings, and we're going to measure it with calipers. And unfortunately, this is part that's going to happen on video. If this were a real class, you'd be able to use the calipers, and that's a valuable thing to be able to do. But, social distancing, what can I say? All right, so we're going to use these calipers. They're electronic calipers, so I have to turn them on. And so let's take a ball bearing here. And so there's 3 parts to the edge of the caliper, a sharp edge, a flat edge, and another flat edge. And the flat part that's right next to the shaft here isn't used by anybody. That's not for use. The sharp edge. If I take the sharp edge and try and do my measurement with that, well, trying to get things exactly on the top, exactly on the bottom is a bit difficult. So instead what I'm going to do is I'm going to use the flat portion here, and that is what's going to get me an accurate measurement. So according to this, my oops, always do that. Okay, according to this, my ball bearing is 13.7 millimeters. Okay, so writing that down then. 13.7. Okay. Oh, but then I notice the instructions say from smallest to largest. This is something that a lot of lab teams do, is they don't read the details. And sure enough, I need to transfer, I did my largest first, so I need to transfer my data like so. So, 13.7. Okay, there we go. All right, so let's go to the smallest. I'm just going to grab one from here because it's easy to grab. Okay. So now I have a measurement of dash 5.2. Okay, where'd that dash come from? Well, anyway, all right. So I've got 5.2. All right, writing that down, and then going on to my next one. I now have like 1.1 around there. What? I went bigger, and my measurement became smaller. What's going on here? Okay, well, okay, it was like there, and when I make my gap larger, my numbers are getting smaller. So I can actually get it to 0, and that's where 0 is with that big gap. So so the problem is, okay, this is what is what 0 should be, and I've got a 0 button. I need to push the 0 button, and now it's got 0. So basically, my calipers were not properly calibrated, and this is an important thing. Whenever you make a measurement, it's important to do calibration. This is apparently, I was recently reading an article that was saying that apparently police departments are not calibrating their breathalyzers. This is an issue. Okay, so let's do this again, this time with properly calibrated calipers. Okay, so again, taking my smallest ball bearing. Now I get a measurement of 6.3. I think that's better. So okay. Okay, so I got 6.3 there. Now my next one is going to be 12.6. The next largest one is going to be, let's see, 19, I guess. Yeah. Oh, but I've already done the largest one. But I did it without proper calibration, so I need to get rid of that number and do this properly calibrated. Okay, so that's what, 25.3? Yeah. Okay. So now, having scratched out a whole bunch of faulty data, I now have the data for my for the diameters of my ball bearings. All right, so now I'm going to turn on my scale and get the weights of the ball bearings. So basically my scale right now is saying 0, and that's good. That means that my my scale is as calibrated as I can get it. And so now I put on the small ball bearing, and I get 1.0. Okay. Then going to the next ball bearing, next size ball bearing, it looks like I've got 8.3. The next size ball bearing, I've got 28.1. Oh, let's see. 28.1. And let me remeasure this. Oh, this time it's telling me 8.4. Well, not significantly different. Tells us a little bit about the accuracy of the scales. Okay, and then the largest ball bearing is giving me 67.1. Okay, so here then is the data for the ball bearing portion. Okay, so after that, you're going to be filling out this table, and here we've got. Okay, so essentially we've got B1 over B2 right here, which means ball bearing 1 over ball bearing 2, and these are diameters. So basically, I'm going to you need to take the diameter of ball bearing 1 and divide it by the diameter of ball bearing 2. Here, the diameter of ball bearing 1 over the diameter of ball bearing 3, and so on, continuing likewise. Then you'll take these numbers and square them for this column. You'll take these numbers and cube them for this column, and then you'll take the weights of the ball bearings. So basically, this will be the weight, the weight of ball bearing 1 over ball bearing 2, the weight of ball bearing 1 over ball bearing 3, and so on. Okay. Then, once you've done that, we're going to take this data and graph it. We're going to treat these three columns like x values, and the fourth column, the weight column, as y values. So basically, first we'll plot diameter ratio versus weight ratio, and so diameter ratio versus weight ratio. Then, and we'll use asterisks for that. Then we'll use diameter ratio squared versus weight ratio on the same graph, but we'll use pluses. Let's see, where is that? There we go. Pluses for that, and then diameter ratio cubed versus weight ratio, and we'll use x's for that. So that is how you do this portion. And then you look at your graphs, and so actually sometimes it's visually nice to actually connect the dots on that, and it's easier to see and draw conclusions from. So then you'll look at that and determine which power of the diameter ratios is closest to the weight ratios. Then we're going to go on and look at bolts. Okay. So it's asking for the length of the bolts. So let's get the length of the bolts. All right, so I'm going to turn it back on. Hello. Oh. Would help if I kept my 0. There we go. Okay. So yeah, I've got a properly calibrated caliper, and now I'm going to take the length of my bolt, which I see as 33.5 here. It may have been slightly different, because these things fluctuate. But then I'm going to take note of the fact that I just measured the small one, and so that's bolt C. So I need to enter my measurement. Oh, actually now it's giving me just 33. No, 33.2. Okay, so I'm going to put 33.2 on C. Okay. And so then going on to B here, I have, let's see, 49.1. Is that what it was? No, wait a minute. Hold on, what's going on here? Yes, 49.1 I think is what, actually, 49.3 is what I'm seeing now. I think that's what I'm going to put. Okay, 49.3. And then finally, 65.6. Okay. Once we have that, once we have that, then we take A over B. Oh, and 65.6. Let me. Yeah, that's about right. Okay. Once we have that, we get ratios of A to B, and I want to clarify something here, and that is whenever I'm asking for ratios, here or earlier or later, when I'm asking for ratios, I want them in decimal form. So it might be tempting to say, oh, A to B, that's going to be 65. There we go. 65.6 to 42.3. And yes, that's a proper ratio, but that's not really going to help us that much. Instead, let's do 65.6 over 42.3, but that's not exactly what we want either. So, let's see. Oh, 49.3, sorry. 9.3, there we go. Okay, so what I want is for you to actually do the division. So, this is going to be 1.05 maybe? I don't have a calculator, plus some other decimals. What I want is about 3 decimals. That's more decimals than you can actually justify with the equipment we've got. I mean, you've seen how the decimals fluctuate with different measurements. And it's actually more decimals than you'll actually need. But for what we're doing, having more decimals is actually better than having fewer, even if we can't justify them. And so yeah, I would say, when you're taking these ratios, do the division, give me about 3 decimal points. Okay. So having done that then, we're now being asked for the area of the threaded portion of the bolts. So let's do a let's get out bolt C. Okay, so here's how we're doing the area of the threaded portion. Well, we've got these these plastic, transparent plastic sheets with rectangles on them, and we're going to be doing areas in terms of numbers of rectangles. We're not going to worry about square inches or square centimeters or anything like that. We're just going to look at the number of rectangles and let the area be a rectangle area. So I'm going to wrap my bolt like this. If I can, there we go. It's not being nice to me. Okay. Okay, so I've got my wrapped bolt, and what we can see here is that it's about 2 rectangles up. Get a little bit better there. Okay, so two. It goes about 2 rectangles up. There's this little bit, this a little gap there. We're not going to worry about that. We're just going to go with a whole number of rectangles. Okay, and another thing I'm going to notice is that when I wrapped this, notice that there are 2 columns of rectangles that weren't involved in the wrapping. So basically, these 2 columns, these 2 columns were involved in the wrapping. These 2 columns were not. So we've got, these 2 these 2 rows, these 2 columns. That means I had a total of 4 rectangles involved in the wrapping of the in the wrapping of the bolt, the threaded portion of the bolt. So that means that I've got, so for C here, I've got 4 rectangles. Okay, make sense? All right. Then the next bolt, I wrap it up. And now hopefully we can see that it's 3 rectangles high. About 3 rectangles high, and there's only 1 column not involved in the wrapping this time. So basically it's going to be 3 by 3. So basically I'll have 9 rectangles in the threaded portion, in the threaded portion of that bolt. And then finally, bolt A. So when I wrap that up, the entire sheet is involved with that. There's no overlap there. So all of the columns are used, all of the rows are used. It's it's 4 by 4, and so that means that I have 16. Rectangles in that bolt. So here then is the data for the area of the threaded portion of the bolts. Okay, so again, we'll take ratios, and then here's kind of a tricky part. Okay, up here, it's asking for an equation that will turn the ratio of lengths to the ratio of areas. So basically, the data that you're going to come up with here, you want to turn those numbers into the numbers you get down here. And I want you to turn those, turn these numbers into these numbers with a single equation. I don't want 3 separate equations for each set of pair of numbers. You should be able to come up with just one equation that does all of them. And then here, you're going to actually use this data and come up with this data and show me that your equation actually works. Okay, and then we come to the elephant problem. All right, so basically the height of my elephant triples, and here's one thing to keep in mind. What triple means. Triple means that you're multiplying by a factor of 3. Okay? So the height is being multiplied by a factor of 3. So to keep the elephant shaped, what has to happen to the length of the elephant? Okay? And what has to happen to the area of the elephant? Hey, here we explored areas of strange shaped things. That should give you a clue as to what's going to be happening to the surface area of the elephant. And then what happens to the volume? I would say go back to the cubes exercise. That will give you a clue as to what happens to that. And then what happens to the weight. Now, one thing that we did with weight was the thing with the graph. You know? We could look at how weights behaved here and try and determine how weights would behave with elephants. Okay, so that is the video portion of the scaling lab. You are now prepared to do the analysis, and that will be due Monday. I hope you do well.